This is why it's really good to think about problems not as an individual, like how do I solve this problem, but how do I solve a problem like this, right? Because the problem today is actually very, very similar to flag. So let's start looking at this problem a bit. Everybody can see my screen, yes? Okay. Thank you, Siham, for being on camera and nodding. I got perfect feedback. Okay, so just a reminder, right? Write a function that takes in a special array and returns its product sum. Okay, so a special array is a non-empty array that contains either integers or other special arrays. The product sum of a special array is the sum of its elements, where element arrays inside it are summed themselves and then multiplied by their level of depth. So this one looks a little bit more complicated. Let's start with these examples first and see if we can understand them. So when we just have a regular array, we are summing this array. So this is 1 plus 2 is 3, 6, 10, 15. And its depth is, I guess we're assuming that if it's one-dimensional, the depth is 1. So 1 times 15 is 15, and we get our expected output. So we go, okay, that seems fair. That makes sense. So let's take a look at this one here and walk through this. So we go, okay. So this is 1 plus 2. So we have a 3. So let's just like keep notes of where we are. So we have up to 3 here. This is a new array. So we're going to have to go in. This is now depth 2. So the sum of this array is 3 times its depth. So this is going to be plus 6, right? Let me know if you're not following. And then we're back in this array, and we have our 4 plus 5, which is 9. So we have our 9, and so we have 3 plus 6 is 9, plus 9 is 18, and that's our expected sum. Okay, that looks good. Let's see let's just walk through these. Hopefully you did something like this on your own. Maybe it helped. If not, oh, that's okay. Okay, so we're here. We're in depth 1. Now we're in depth 2. So we're going to take the sum times the depth. So we would say 1 plus 2 is 3 times 2 is 6. So this is going to be 6 plus our 3, because this is still just depth, plus, and we would say 4 plus 5 is 9, plus its depth is 8, or times its depth being 2 here is 18. So then we're saying 6 plus 3 is 9, plus 18 is 27 times its depth, which is now 1, and we get is 27. So that works as well. Lastly, now that we're kind of getting the hang of it, let's do it with the most complicated one here. So we go 5 plus 2. This is going to be 7. Plus whatever we get back here. So this is going to be 7 plus negative 1 is 6. And then this is a depth of 2. So this is going to be 2 times 6 is 12. Plus 3. Plus, and then we have to dive in. Let's dive into here first, because that's this is going to be, well, I'll just kind of do math here, I guess. 2 times whatever we get back from all this. So we'll go on the inside first. That feels more intuitive to me, but we'll remember we haven't included the 6. So negative 13 plus 8 is negative 5. And this is in depth 3, right? So 3 times negative 5 is negative 15. And this is going to be plus 6, which is going to bring us down to negative 9, plus 4, which is going to be negative 5. This is a depth of 2. Negative 5 times 2 is negative 10, right? And then we should add these together. So we'll get negative 10 plus 3 and 7 wipes those out, and all we're left is 12, right? So,
Corey, I have a question.
yes.
For the example 3, how did you get the +6 for the special array 3?
Great. Good question. So 3, what's the sum of this array?
You have the 1 plus
Just
2.
the sum of the array that I'm highlighting?
Oh, 3.
Right. And what depth is that at?
1.
So actually, that's a good question. So this depth, the original array is depth 1, but this is an array inside of that. So this is now depth 2.
Ah, okay.
So 2 times 3 is 6.
Oh, okay, I got it. So so comparing it to the one that you just did, the first example.
Mm-hmm.
So 6, yeah, that one is a depth of 1, 2, 3, 4.
So not quite. So this one is in depth 1.
Okay.
This is depth 2. This is depth 2. And this is depth 3.
Oh, okay. Okay. It's hard to understand how it's like set up.
Yeah, it's a little confusing, right?
Yeah, okay.
Anybody else have questions on that too? This is kind of like understanding the problem is half of the problem, right? And recognizing that this could potentially be flattened, right? Because it's just flattened with a slight added twist. And that added twist is we have to keep track of a depth and a sum. So let's kind of talk about it here. So we'll say const special array product sum, I don't know. And it's going to take in an array. Is there anything else we might want to pass into this?
The level.
Yeah, right? The level or depth, right? So I'm going to call it depth just because I like that word. But yeah, you could totally call it level, right? So in this case, right, we're going to take in this array and we're going to take in this depth. So we're going to find the sum of this array and then we're going to multiply it by its depth. And that's what we're going to return. Right, that's the idea. So if it was this, we'd take the sum, multiply it. If we take this, as soon as we hit this array though, we have to find the sum product of this array. And only once we get that, once we get this, whatever we got back from this, I think it was a 12, right? 7 is 6 times 2 is 12. Yeah, so whenever we get to 12, then we can go ahead and include that back with our running total from 7, and then we would have our 19. Right? So we have this same kind of idea of checking this element. If this is an element that we can use, we'll just add it to a sum, and at the end we'll return that sum times its depth. If it's not something we can use, we'll go ahead and call special array on this array and increase its depth by 1, and then wait until we get the sum back. I think I can see there's something in the chat. Are we doing depth 1 because we're flattening it first? So good question, Dragobasi. So we're not actually flattening it first. We're doing it at the exact same time. We're starting at 1 because, well, we don't want to multiply anything by 0 because that would negate everything we do, right? As soon as we have something that has a 0 in there, everything becomes 0 because 0 times anything is 0. So it's better for us to start at 1 instead of 0 so that we can actually get results back. But also we're going by arrays themselves. So every time we hit an array, we have a depth of 1 more than the array that we're inside. So if we're in the first array, we have a depth of 1. That's why we see this example from example 2, where we get 15, it may look like it's just the sum of these numbers, but it's more than that. It's the sum times this depth, which is 1.
Okay. Thank you.
No problem. If that doesn't make complete sense, let me know. So, okay, so if we're going through this, right, we can go ahead and start up with a sum variable, like let sum. And what's a good number for sum to start with?
0.
0.
That's right, because anything plus that is going to be anything, right? So, and we also know, well, I'll not worry about that yet. So then we're going to iterate through this array, same as we did for flat. So each one of these is an element. And we have to check, is this an element that's ready to be added to our sum? If it is, we will. Otherwise, that means we have an array, right? So is this an array or is this not an array? That's really the two options. So we say, hey, if array dot is array element. So if this is in fact an array, we're going to go do something. Let's not worry about that quite yet. Else, we'll just add it to our sum. Plus equals our element. And then, so if this was our example 2, right, we would go through it and our first element would be 1. We'd add that. Our sum would be 1. Our next element would be 2. It's not an array, so we would just add that. And then we would add the 3, the 4, the 5, and we would have 15. But we can't just return the sum because it's the sum times its depth. So we're going to say return sum times depth, right? So in that sense, what if we have this array, right? What if we're back to kind of like example 3 where we have this array on our third element. So right now our sum is 3 and we do have an array. Okay, so if we do have an array, we can't just go like sum plus equals element. We can't do that because element is an array here, right? And we can't do math like that. So we have to assume, we have to do that little bit of magic where we go, okay, well, special array product sum is going to return the product and sum of the array. If I believe that this method will work, then I can assume I get that number back. So if I can assume I'm going to get that number back, I can call special array product sum, pass in the element, which is really an array, and I have to change the depth because I need this call to give me back a 6. So this is just going to be depth plus 1. Oops, plus 1. So whatever the depth was before, which I'm having a default to 1, I'm just going to call what the depth is and plus 1. Now I'm not going to reassign the value depth because they may be looking. Instead, I'm just going to say depth plus 1. So what does that mean? So let's say we were doing this example 3 example. And so right now our sum is 3 because we've gone through the first 2 and we're here. And we go, oh, I don't know why that happened. And we go, okay, is this an array? And the answer is, of course, yes, this is an array. So we go, okay, we're going to call special sum on this array with the depth of 2. So our sum resets to 0. So right now our sum looks like this. And we have one element in the array. So we're going to go array dot for each. So right now the element is 3. And we go, is this an array? Well, no, because we're calling it on this whole array, right? So we're just on this element 3. So sum plus equals 3. So right now our sum value is 3, right? And our depth, though, is 2. So it goes return 3 times 2 is 6. And so this evaluates when passed in our array of 3 and depth 2, this evaluates the 6. So now sum is going to equal 9 because it's going to be the original 3 from the first call plus the 6 that this returned to. So then we have our 9. And then we're going to go ahead and keep going. We'll have the element of the 4. 4 plus is not an array. And 9 plus 4 is 13. And then the next element in the array is a 5. And we would say that's not an array. And so 14, well, I forgot what number I was on, to be honest. That's my mistake. 13 plus 5 is 18. And then we return sum. And our depth originally was 1. So that's just 18 times 1. Okay, so let's go ahead and try these out as good tests. So this one is by far the most interesting one.
Real quick,
Yes.
just to make sure, this is recursion, right?
Yeah. This is
Okay, cool.
recursion. This is any function that calls itself is considered a recursive function. But it's kind of an interesting mix, right? Because there is an aspect of iteration to it. That's what makes this problem so fun. One of the things that makes this fun. So let's node our warm-up, and we get 12, which is the goal. So this totally works. Again, let's do this as if we were using reduce too, right? So this is one solution, but we could do this with reduce too. Const reduce, and this takes in an array, and the depth, which will still equal 1, right? So this is going to be very similar, right? I'll remind you to what our flatten looked like before, right? This was we had a result array, and we were just flattening and concatenating or pushing, and then when we did the reduce, we just returned array reduce. Our accumulator was our result, and the logic was essentially the same, right? Hopefully you can see the similarity between this function and this function, right? They're nearly the same. It's just instead of an array, we have a 0. Instead of concatenating the flatten, we're just adding. And at the end, instead of just returning the result, we're returning our sum times the depth. It's pretty much the exact same problem. So let's go ahead and try this with reduce. So we know we need to return. So just like before, we just returned the reduce, which was essentially the output array, the result. But in this case, we return the sum times the depth. So I'm just going to go ahead and return our depth times our whatever we get back from reduce. So array.reduce, and we can call this sum and element, and this is going to default to the value of 0, right? And so now we have essentially the same logic. So if array dot is array of our element, so if this is in fact an array, then we can just go ahead and say sum plus equals, oops, and we can call our special array product sum with our element as well as an increase in our depth. Else, we can say sum plus equals element, and we need to return sum so that we have that for the next iteration. And that's pretty much the whole problem. So let's just check our work. Should get 12, and we do. Right, so again, pretty much the same problem. We can clean this up. We can make it, we can play golf with it if we want. You know, like I'm kind of personally, I don't like that it says sum plus equals this and sum plus equals this. I'd rather it say sum plus equals and whatever we get back. So we could make that in a ternary, like is array L, and then we would say, so if this is an array, We'll take this line and put that here. Otherwise, we'll just say element, and then we don't need any of this code, right? Then we get our 12. I think we could even say like return sum plus, probably. Let's see. Nope. Maybe I can say sum plus equals, maybe. Let me see. It might not work. Oh, it does work. Okay. Right, so you can really make it short looking if you want to play golf. Honestly, this is more readable. I like this solution more because it's more readable. This solution's fun because it's one line, right? I mean, you can get rid of everything if you wanted to. If you want to get crazy, you don't need any of this. Right. Technically still works. But it's hard to read. Any questions? Any questions at all? So if I ask us a different kind of flag next week, will we know it? Are we ready to take that challenge next week?
I'm
Yeah.
down
What?
I think so.
about it.
Okay. Right, so just keep track of like this kind of pattern. There's so many types of problems that are, it's so pattern driven, so many of these. This really is flat, just with one extra variable and doing addition instead of dealing with an array. All right. Any other questions at all about any of it? Now's a great time to ask if you do have questions. All right. I guess
Maybe
not.
can you just go over the function flatten again?
Sure. Yeah. So in flatten, we are asked to write a function that takes in a multidimensional array and returns a flattened array. So it's like it could take an array like this and return it all sequentially there without all the other arrays. And so the way this was done, right, is we kept track of this result array, and this was going to be our flat array. And we iterate through the array, and because all we really care about is this element an array or is this not an array? If it's not an array, I can just push it in like normal into the result, right? Because if it's not an array, it's not causing another dimension in the array. Only when I have another array is that whole dimension. So if it's just a regular element, I don't care. I don't have to think about it. If it is, though, actually an array, right, this is what's causing it to be multidimensional. So I'm going to need to flatten this array. I can't push it in. If I were to push it in, because this, when I call flatten, this is going to actually return, right, the result, which is going to be, we have to trust that this will work. It's going to return a one-dimensional array. That's the whole point, right? Because that's flatten. So we know whenever you call flatten on something, it returns a one-dimensional array. So if we believe that, if we can accept that, we know when we call flatten on the element that this is going to evaluate to some one-dimensional array. We don't care what it is, or what it looks like. We just care that this is a one-dimensional array that flatten of the element has evaluated to. And so once we know that we have a one-dimensional array, we have to add that array into our current result. And so we can't push it because then we would have a multi-dimensional array again. So we can concat, because concat is just joining those, right? Another way I could write this, which maybe you might be more familiar with at this point, would be to say like result. I can use the spread operator. Do the same thing, right? So this is essentially saying result is going to equal to whatever result was, as well as whatever we get back from flatten.
Oh, okay.
And that's how flatten is, right? So as long as it keeps adding that in, our array is going to stay one-dimensional. And then at the very end, we'll return that one-dimensional array. In the event that we do hit an array, well, we'll just call flatten on that and make sure we get back our one-dimensional array, which will then be smoothed into whatever the current result is, which is one-dimensional. And then we'll return that at the end.
Okay. Okay, that makes sense.
Right, so
And
the
then-
compare, yeah.
Yeah. No, go ahead.
Well, I was going to say, and so when we compare that to this answer, I mean, our eyes should already be telling us there's a lot of similarity just in the shape, right?
Mm-hmm.
The difference is we're keeping track of this depth because we have to multiply it by its depth. We don't care about a results array because we're not trying to flatten the array. We're just trying to get the sum. So we have a different like base here. Did somebody just jump in the queue? Yes. I'll be with you in a minute. We have we're still doing the same iteration, right? If we have an element that's not an array, we can just add that because you can add numbers to a number, right? We just can't add an array to a number. And at the very end, whatever the sum is, we multiply it by its depth. And if we can accept that special array product sum is always going to return an array that has the product of an array times its depth, well, then we can go ahead and accept that we can take whatever sum is plus equals, if we hit an array, we can get whatever this evaluates to. Whoops, sorry, I didn't mean to have else highlighted. Whatever this evaluates to. So whatever this element is, this array's sum plus or multiplied by its depth, which is going to be one deeper because we are having to call it. So we're going inside of a recursive call, which means we'll have to increment our depth by 1.
Okay. Okay, so then my next question is, if you scroll up just a little bit to the example, okay, boom. For the first example, did you know that the special array 6, array -13, 8, 4, did you know that that was on the second depth because 3 is the pivot number?
So there's no pivots in this at all. It's just iterating through and checking to see if that element is an array or not. So when we met this element, right? This is one element.
Mm-hmm.
So we call, and this element was an array. So we would call a special array product sum on this element, which is this whole array, and our depth plus 1. So originally our depth was 1 when we were in this array, but when we had to call it on this, our depth becomes 2.
I thought it changed once we did, I thought the depth changed once we did the first special array, the 7, -1.
So these are mutually exclusive calls, which means they have nothing, like they don't really have anything to do with each other. There's no overlap. So
Okay.
this has a depth of 2. This has a depth of 1, but this also has a depth of 2 because we never like reassigned the value of depth. This isn't us going like this. depth plus equals 1, and then put depth in here. If we did that, it would no longer work. If we did, here, this is a really interesting point, Ashia, that I think you're bringing up. If we did depth plus equals 1, this shouldn't work either. And let me just prove it to myself, just to make sure before I rant on it. We should end up with a number too high. Yeah, or way low, right? So we get negative 54. Can anybody else explain why that's happening? Does anyone want to take a stab at that? Don't be shy.
Can you repeat that last section one more time? I'm sorry, I got a bit lost. Just that last thing you just said.
So the only thing I changed in my code is I said depth plus equals 1.
And you want us to explain that?
Why are we getting negative 54 now? Why can we not do this?
You're reassigning the value.
But why, and why is that a problem, Doug?
Because you're like updating the actual value rather than just adding 1 to it. So when you pass it back in, the number becomes higher. So once you multiply the negative number, I believe, it's going to be higher than what it's supposed to be.
Exactly. Thank you, Doug. So just to reiterate what Doug's saying is, right, this is assignment. So this is actually taking the value of depth and reassigning it to 1 more than it currently is. So if that's the case, as soon as we've done that, sorry, I went way too high. As soon as we've done that, from here onwards, depth would now equal 2. Once we got to here, depth would now equal 3. Once we got to here, depth would now equal 4. And it would just, but this depth would also be changing. So this depth would now also, the whole depth of everything is now 4. So it leads to a lot of messiness. So that's why we have to instead do +1, because we don't actually want to do reassignment. And so because of that, none of the calls are affecting each other, which is, I think, essentially where this started, which was like, well, how come that first call to 7 and 1 doesn't affect our 6 and onwards?
Yeah.
Because
Okay.
we're not actually doing any reassignment. Now, can anybody tell me, in the nonverbal feedback feature, give me a yes or no if this works. If we could just say depth plus plus. Is this okay? Will this work?
Yeah.
We've only got 9 responses. Come on, take your bet. Don't be shy. Okay, so this is great. We're like pretty split in the class. This is awesome. So somebody from the red side, maybe Ujwakabasi, I see you're a no. If you have a mic, can you tell us why depth plus plus, you don't believe depth plus plus will work?
So at first I had yes, but then I remembered, like, isn't plus plus equal to, isn't that the same thing as +1?
Isn't it the same thing as what?
Plus or equal to, or maybe I'm like misspelling that.
Yeah, I think you're right, Ujwakabasi. Right, so what Dee's saying is plus a variable plus plus is the same thing as a variable plus equals 1. Right, so plus plus is just syntactic sugar for something that's already syntactic sugar. This is pretty specific to JavaScript. Let's try it to prove ourselves. Let's see if we're going to get negative 54 or we're going to get something else. So we get something totally different. Don't know why it's not negative 54, but it's definitely not 12, right? How about this? Is this gonna work?
I've never seen that one before.
Give me a yes or no if this will work in the nonverbal feedback feature. By the way, I think the reason that other one is like 48 is because I think it's the reassignment might be happening like a little bit after. It might be happening a little late in the call or something. But I'm not 100%. So, okay, this time we're getting a lot more no's. All right, do we have any guesses on what number it's going to produce? Okay, Henry's guessed 48. Any other? What's our number going to be? Anyone know? It's okay if you don't. I don't really know either. I'm going to guess negative 54. That's going to be my guess. But we'll see. I could be totally wrong. Ah, I got it. Great success. So the reason this is different, right, is if you remember the order of this versus this has different implications, which we can show with our node, right? If I have a variable, let num, let's say this is 5, right? I can say console.log num plus plus, and what do we get? We get 5, even though console log of num is 6, right? Because this happened after. So num is now 6. If I console log num, this is just kind of like quirks of JavaScript, right? Now we're going to get 7 because then the addition happens first. So now if we console log our num, we have 7. If we console log num plus equals 1, what do we think we're going to get? You can write in the chat. What are we going to get? Seeing a lot of 8s. Thank you, Henry, Kong, Maria, Siham, Marvin. Thank you for writing. Ashia, thank you. Okay, let's give this a shot. We do. We see 8, right? Because this behavior mimics this behavior. This behavior takes effect a little after. So that's why when we make our depth like this, we're getting a different answer than when we did plus equals 1, because we're calling that function with a different depth, and this is happening like one step after the product already came. It's kind of confusing. Not really the point of, well, it's kind of the point of the lesson in a sense, right? Like that's something to be aware of, and that's why we're not doing any of this reassignment, and instead we're just saying depth plus 1, because we do not want to change the value of depth, and we want this to happen right away. So I'm going to escape my node, warm up, and we get our 12. Okay, and that is the whole shebang. Any other questions on this? All right, cool. I'm gonna stop the share. I'm gonna stop recording.